Hi everyone. So this video is to show you how to design a patch antenna. Okay, include like how to calculate the dimension. Okay, why we can have like 38.39 and the width and the length like 29.77 of the length here. The width is 38 and the feed line will be like 3.11 and the length of the feed line will be like 17.29. Okay. Other than that, I will also show you the S11. Okay, we calculate, let's say the S11 is like 2.4 and how we get the data for like simulate for the S11 as 2.45. Okay, and also how to get the far field 2.45 and 2.4, so we can have our gain is like 1.987. Okay, you can see it's like directional antenna because of the patch antenna with like full grounded. Okay, that's why only directional. And then 2.4, okay, they have like the gain is 1.988. Okay, so for the design, okay, so how we get this value, okay, 38.39, and how we get the feed is like 3.11. Okay, so the calculation will be, you can go to Google here and click on like patch antenna calculator. So you can click on here, you can choose like image and click on this one. Okay, so let's say we know our material of the substrate of the dielectric constant, so we're using FR4, so CST FR4 is 4.3. Okay, what I mean is here, so we have the FR4 and the value for the substrate here. Okay, here is like the value is 4.3 here. Okay, and the thickness is 1.6. So in calculator we will put like 4.3 and 1.6. Okay, and then the frequency will be like 2.4. So synthesize it, we get like 29.77 and 38.39. So the length 29.77 and the width will be 38.39. Okay, so go back to the CST. So you can see here it's like 38.39 for the width. Okay, yeah, for the width, and 29.77 for the length here. Okay, so exactly same as the calculator here. Okay, then how about the feed line? That means here, this feed. Okay, we can go for like the patch here and click on the feed line antenna calculator. Then we have this. So this is the microstrip line calculator to calculate the feed. So here will be like 4.3 and the thickness will be like same 1.6 mm for the FR4 and gigahertz will be like 2.4, the frequency 50 ohm because our SMA is 50 ohm and quarter wavelength. So synthesize it, then we will get the width and length. So you can see the width here is 3.11 and the length here will be like 17.29. Okay, so you go back to the 60 here, 3.11 for the width and the length is 17.29 here. Okay, so sometimes you also can click on the simulation, big face here, and you can choose the length here. Okay, so it's like 17.29. All right, so later I will show you how to make the slot for here as well. First, to design this, we're going to like create the new project here, open a new project, then new template. You go to microwave and antenna. Next, click on patch planner. Next, time domain. Next, dimension will be like mm, gigahertz, nanosecond, Kelvin. Next, the setting of the frequency, we're going to simulate for 2.4 and 2.45, so we can say like 1 giga to 3 giga. Okay, here the monitor we can like skip it first while we have the good S parameter S11, then only we will click on the frequency that we want to monitor. Okay, so next, so just click on finish. Okay, so we're done for the template here now. Okay, so our unit will follow just now what we set, and we also can see from here the frequency that we set is here, simulation frequency. So just now I said 1, 2, 3. So we still can change it here. Okay. Okay. To design the patch, right? So we're going to design the layer by layer. Okay, so we have 3 layers. You can see a copper, substrate, and a copper on the top. Something like this. Ground, substrate, and another ground is for the design. Okay, so you can see from here it's the same ground, substrate, and the design. So we have 3 layers. So first, we're going to go back to our template here, go for modeling, and click on the brick here. Then press on escape. Okay, we will define the first layer, ground. So our ground dimension will be, we will define it as like W divide 2 and W divide 2. And then L divide 2 and L divide 2. And the thickness will be copper thickness. Okay, what is the W and the L means? That means it's something like here. So we have the, you can see here, the patch design is here. So we have another like substrate, and the copper ground here will be greater than, the size will be larger than the patch. So let's say we know our L and the W for the patch is 29.77 and 38.34. So we can assume we're going to greater than it, then we can click on preview. But before we click on preview, we're going to choose the material, load from the library, click on copper. Okay, load it, then click preview. So they will ask for the parameter. So we make it like greater than the patch, right? So we make it like 50 and 50. And the copper is thickness is like 0.035 for PCB FR4. So okay. So we have a ground now. Okay. Why we going to put like negative negative like this? Because of our coordinate is in the middle here. So positive of the W and negative of the W divide 2, that means you have like the whole length will be W. Okay, that's why we can put it 50 and divide 2 will be like 25 here, 25 here. Same go to the L. Okay, up and down. So click OK. Then we have this. If you want to check the coordinate, actually you can click on here. The coordinate actually is here. Okay, so when we want to put up like here, now we have the thickness, so we can choose like the big face here, and we click on here, then we know okay the thickness is 0.035. So we also can click on D, press D, then they will clear, and click on another big face, double click on here, then you can see that it's like 50 mm. Okay, the whole length. Okay, so when we're going to design, and second layer will be like on top of here, so we can choose like big face on this surface. Okay, on the surface on the top, then we can click on this align WCS. That means this coordinate will go up. Click here. Okay, now it's on the top of the copper now. So we're going to design the substrate, something like this. The substrate for this, the height for the FR4. So next, we're going to click on the brick, then click escape, and then we name it substrate. Then here will be like negative substrate width. Okay, the substrate will be the same, so we can just name it as W divide 2 is the same size. So W divide 2 use by the variable. So L divide 2 and L divide 2. Okay, so the thickness. So substrate thickness is 1.6. Okay, as we define here, 1.6. So go back to the design. So our material will be FR4. So you can click on F, choose lossy. Okay, lossy free is total loss, low with no loss. That means we need to choose like lossy. So load and press preview. If you want to preview, then the thickness will be like 1.6 mm. Click OK. So you will have something like this on the top. Okay. So press OK. Then you have your substrate now. Okay. So next, we're going to design the feed line. Okay. The feed here. Okay. So how are you going to design it? You can choose the feed point here. Choose the center to click on this line. Okay, that means we'll be starting here. So we're going to like design from here to top. Okay, so click on align. Then the coordinate will be starting from this point. Okay, so we will click on like the brick. Okay, so we click press escape. Then this one will be like feed line. Okay, then we will define this one will be like feed line. Okay, feed W divide 2, and then feed W divide 2. Then don't worry about the capital, that doesn't affect. Okay, so feed L divide 2 and feed L divide 2. Okay, and the thickness will be the copper. So you can see from here is copper, so same as the ground thickness. Then we go back to CST, is copper. Alright, so we click OK. So the width will be, just now we calculate it, is like here 3.11, and the length will be like 17.29. So 3.11, 17.29. Okay. Okay, but you can see it's like actually like going out of the design because we have negative here. That means V coordinate negative, they will go behind here. So we can change here by putting 0 preview. Okay, but here will be a shorter, then that means divide 2. So we're not dividing because we need the length will be like 17.29. So okay, so that is, then this will be good, and then press OK. Okay, but okay, now you see another problem here is the material of the feed line is FR4. Okay, we can change it, don't worry. Just right click, assign the material, choose material copper, then press OK. Then will automatically change to copper. So now you can see like 3 layers: copper, substrate, and the ground copper. Okay, now we're going to design the patch. So we can move the coordinate to here. So we can choose the big point, center on here, then align. Okay, but we need to careful because our starting point is here, then we need to careful the thickness of the copper here. So I will show you why. Now we going to back to our design. So we know our width and the length of the copper design for the patch is 29.77 and 38.39. Okay, so go to the brick, then we will design like patch. So here will be like negative patch W divide 2. Okay, patch W divide 2 and patch L divide 2 and patch L divide 2. Okay, and the thickness. So we need to careful about the thickness because now our coordinate is on top of here. So our thickness will going down. So we're going to put like negative copper. Okay, then we click on preview. So the patch is like the width is 38.39 and the length will be 17.29. Oh, okay, so they have an error here. Okay, then again, the length of the patch is 17.29, then okay, so done. Okay, but now we found out another issue is, yeah, the length here. So as the same, we just put 0 and delete this one. Okay, then it's on top here. Okay, why I mentioned the thickness we need to have a negative, because we going to put it down. Okay, so you can see at the same line for this feed line, the copper. So if I put positive, that means it will be on top. Okay, so we don't want something like this. Okay, we want it same align with the feed line here. So that means we need to put negative. So it's like negative will be like negative 0.3, 0.035. Okay, so align with the feed line. So choose the material, copper, then press OK. Okay, now we are connected. So you can zoom in, zoom out using your scroll. So now you've done this, then we need to have a slot here. Okay, so we know our slot is like 14 mm here, and the length will be like 5 mm. Okay, so next we're going to design a brick, okay, to like a slot here to intersect it. So we make it like, we call it like slot, and then this one will be like negative slot width divided 2, and then slot width divided 2, and then here will be the length will be like slot length will be like 5 mm, and same copper thickness. Okay, so we will have something like, here is 14, here is 5. Okay, so we have something like this now. Okay, so it looks good, align. So we just press OK. So now you can see they have a slot here. So how to like remove this slot? Okay, you can choose the patch. So this is the whole patch. Click on Boolean here, click on subtract, and click on the slot, then just press enter. Okay, now you can see it's removed. Okay, now how I'm going to connect my feed line to the patch here. Okay, so don't worry, we know the length here is 5, so we can just create feed line 2. Okay, so here will be the slot W by 2, and slot W divided 2, and here will be the slot length. Okay, because it's like 5 mm here, same, and here will be like negative copper. Okay, so preview. Okay, so we go actually need is the feed line, so we should not use the slot, we should use the feed line W divided 2, and the feed line W divided 2 here. Okay, so now we have the connection, so we just press OK. So it's connected now. Okay, so everything is good now. Then we're going to define the port. Okay, the waveguide port here. So the waveguide port is something like this, but how are you going to know the dimension? So don't worry, you just click on pick face here. Okay, on here. So choose here and choose this. Okay, on here. Why? Because they have a guideline here that mention you need to choose on this side is something like home. Go to the macro, solver, ports, calculate the port extension. Okay, then you will put out this calculate port extension coefficient. Then you can check it like automatic 3.11 because we choose the big face here. They know our width, and then they know our height of our substrate 1.6, and the material property is 4.3. So we need to calculate the K to like times with our height. So how big of the waveguide port? So just calculate it, then choose the recommended one. Just click on construct peak phase. Wait for a while, they automatically create it. So now you're done. Okay, once you're done your peak phase here, but slightly a bit weird from this side because it's 17.29. Okay, that means something like maybe our parameter list here, our width or patch length. So check again. Our patch length is 29.77. So change it again. We can change it automatic here and then click update F7. Okay, now looks good. It's almost same as the design here. Okay, so next we can just like click on simulate it, and then we can choose the accuracy. We can make it like 30. The lower the more accurate, but we can choose 30 is enough. And we only have one port, so we can just click on all port is okay because only one port. Then click on start. Okay, while start simulate, need to wait for a while for finish simulate the antenna and get our S parameter result. Okay, so once finish the simulation, okay, so you can go for like 1D result, check on your S parameter. So you can click on the axis, then move to the point that you want to view, or you can click on double click on the axis. Let's say you can click on choose like 2.4, then press OK. So we have our 2.4 now is like negative 32.408. Okay, so it's good. That means our reflection is lower than negative 10 dB. Okay, so and now let's say we are satisfied with this result for the S parameter, then we can go and set like the far field. At the far field, so we go to field monitor here, simulation, field monitor, and then choose for far field and 2.4. Okay, apply. So you can see automatic like pop out here. And we also can check on the surface current 2.4. Click on apply, then it will pop out here. So then okay. Oops. Okay, so because we have already, then we can just close it. Then we have two. Then we just run again the simulation, so they will help us to simulate the far field and the hash field for the surface current. So now our far field here 2D and far field here is empty. So once we simulate, then we will have the data here. So we run it, start again, then wait for a while, wait until finish simulate, then we can have a hash field, far field, and the surface current here. Okay, so done for the simulation for far field, then we can check for far field result here. Click on far field 2.4. Okay, here is directivity of your antenna, and you can choose for gain. So your gain will be like 1.988 dB, and click on linear so you can check your designs, show the substrate. Okay, so you can see the bin is directional antenna. Okay, they're showing something like this, one direction only. Okay, and here because of the full ground plane here, so you don't have signal will radiate behind here. Okay, so you also can view like in polar form. Okay, so it's like directional. So how we know our angular width will be like 94.7 degree. That means like 3 dB here, and here is 94.7 degree, and our gain is 1.99 when we choose here. Okay, so next, if you want to watch your surface current, you can click on here, click on smart scaling and dB, and you can animate it. Okay, so you can see the surface current is moving from your port, waveguide port here, go up and radiate, distribute to your patch antenna. Okay, if your, let's say, let's say I do another one is like 2 gigahertz, something like this. 2 gigahertz here. That means you can see the S1, what you can view the S11 here is not good because it's like reflect, most of the signal is reflected. So the surface current of 2 gigahertz will be only should be this side and reflected back to the port. They won't distribute to the patch here. Okay, so but first I will show you the how to calculate the bandwidth. So the bandwidth usually we will do something like this, but and we can do it like marker axis, measure line. So we can put on like two line here, 10 dB, another 10 dB here. Okay, so now we have like 2.44. Okay, then we can move this one on the top here. Okay, so 2.44 minus with 2.35, then you will get your bandwidth of your antenna design. Okay, so I will show you another one is like surface current for 2 gigahertz. So you just click on the simulation, go back to the component here, click on simulate as parameter, component, simulation, field monitor, choose on H field, surface current, 2 gigahertz. Press OK. Then they will have like H field here. Just simulate again. Okay, just wait for a while to compare the surface current 2.4 and 2 gigahertz. So you can see the difference of like how the surface current distribute in your patch. Okay, once done the simulation, okay, so we can check on like 2 gigahertz here and we click on smart and dB and we can animate it. So you can see the red color arrow here is stuck on this side. That means right, there actually is not matching network. That means the feed line here, they will stop at here. They doesn't distribute to the patch. So it go again for 2.4. So you can see the difference. The red color is distributed to the whole antenna, the patch. Okay. So this is the difference. So another one. So let's say your exercise is like request you to design a patch is 2.45. So how you going to set it like 2.45 here? You can use another method. This is why we choose all the dimensions like variable. So you can do like simulation here. Click on simulation, parameter strip, and click on new sequence and new parameter. That means you're going to like do the parameter strip for the variable. So let's say we choose a slot and we're going to set it like 5 to 20. That means right, just now our slot here is like 14. That means it's like the slot here. Oops. I will show you again. So let's say we click OK, wait for a while, choose 4 sample. Why we choose 4 sample? That means we're going to parameter strip from 5, 10, 15, 20. That's why we need 4 sample. We just click on OK, but don't click start yet. We close it. So I will show you why here. So let's say we have the slot now is 14, right? Let's say I change to 5. Okay, then you can see here the slot here will become smaller. Okay, so when I click, then I need to delete all the result. And then I click F7 to update the parameter. So F7. Okay, so you can see the size of the slot is smaller. Okay, so this is what the difference of the parameter strip. So now let's say I run it, the parameter strip. Okay, so I'm going to change it like just now it's like 5, 10, 15, 20, 4 sample. Click OK. This will take time because it's like 4 simulation. Okay, so start, then wait for a while until it complete. Okay, so you can see like 1 of 4 out of 4. So they will have 4 times. Just wait for a while. Okay, so when done the simulation, so you can check from your result as parameter here. So now you can see they have like extra few lines because of the parameter strip. We have 5, the width of the slot, 10, 15, and 20. So we can double click on here. So let's say we reduce the size of the slot W to 5, then you can see the frequency is shift to the left, lower frequency. If 10, that means also lower frequency, shift to the left. So let's say 14 is here, 2.4, and 15, okay, slightly right side. And then 20, we can check on here is like 2.45. Okay, so that means we going to change our slot to 20. Okay, slot width to 20. That means we can get our design to 2.45. Okay, so from here you can just go to the parameter list here, change to 20. Yeah, just now we already simulate, so they automatically change to the latest number, that means 20. So now our width here is 20. So we can click on big face here, this line, okay, is 20 now. Okay, so now we have 2.45, right? So we can delete all this like H field. Okay, if you don't want to see the H field, we can double click on far field, change to 2.45. So click OK, then we can start simulate for 2.45 far field. Okay, so wait for a while. Okay, so done for the simulation. Then you can go for far field 2.45 here, and then check on the 3D and the polar. So this is the polar form. Your click on far field, and your gain will be like 1.96. So let's check on 3D. Okay, your gain is like 1.958. It's like 1.96. So if you click on linear, so you can see also it's a directional antenna. Okay, so now is okay, so that's all for how to design the patch antenna and also how to do the parameter strip for your design. If you want to like export your data, so you can view another video. So how to plot data, export your data to ASCII, and then how you plot your 1D polar form 3D radiation pattern. Okay, your polar form radiation in Sigma plot. Okay, so that's all. Thank you.